At the bottom of the world, where temperatures routinely plunge below negative 112 degrees Fahrenheit and storms can rip apart steel like paper, a handful of strange, futuristic structures are fighting just to stay alive. These aren't just buildings. These are survival machines. Today, we're going inside 5 Antarctic megabases engineered to withstand the most hostile continent on Earth. A place that crashes, buries, freezes, or blows away anything humans try to build. Antarctica isn't just cold. It's alive. Ice shelves drift like slow-moving rivers, carrying entire research stations with them. Snowfall piles up so relentlessly that some bases vanish beneath the ice. Winds scream across the landscape at hurricane-level speeds. And when winter arrives, the sun disappears for months, plunging crews into total darkness and isolation. Yet, despite the dangers, countries from around the world continue building outposts here, each one a different engineering experiment in survival. Some stations perch on massive steel stilts. Others float atop shifting ice shelves. A few can literally move across the ice to outrun destruction. Today, we're exploring 5 of the most extreme megabases ever built in Antarctica. Structures designed not just to operate in the coldest place on Earth, but to withstand anything. Number 1. Halley 6 Research Station, United Kingdom. Our first megabase is a true engineering marvel. The Halley Research Station sits on the Brunt Ice Shelf, a floating platform of ice that slowly drifts out to sea. The British Antarctic Survey has operated bases here since 1956, but every single one of the early stations eventually disappeared. They were either buried under snow, crushed by shifting ice, or carried away toward the sea. Halley 6 had to break that cycle, and it did. Opened in 2013 at a cost of $33 million, Halley 6 is the world's first fully relocatable polar research station. The station consists of 8 interconnected modules, each mounted on giant hydraulic legs and massive skis. If cracks open in the ice, which they regularly do, the entire megabase can be unplugged, lifted, and towed to safety by tractors. Each module was built in Cape Town, South Africa, then shipped to Antarctica and assembled like a giant life-size Lego set. Once fully assembled, the station stood high above the snow on telescoping legs that can be jacked up as snow accumulates, preventing burial. Halley 6 isn't just built to survive. It's built to keep its crew mentally healthy. Designers worked with a color psychologist to choose interior colors that counteract the 100 days of total darkness each year. Living modules have daylight simulation alarm clocks, warm wood veneers to mimic natural environments, and carefully engineered lighting to stabilize human biorhythms. Since opening, Halley 6 has survived coolant leaks during temperatures below negative 67 degrees Fahrenheit, major ice cracks that forced emergency relocation, and storms that tested its design to the limit. The station continues operating today as one of the world's most resilient scientific outposts, and the birthplace of one of humanity's most important discoveries, the ozone hole, detected from early Halley stations in 1985. Number 2. Neumayer Station 3, Germany. Next is one of the sleekest and most modern megabases in Antarctica, Neumayer Station 3, operated year-round by the Alfred Wegener Institute. Completed in 2009 on the Ekstrom ice shelf, Neumayer 3 replaced 2 earlier German stations that suffered the same fate as many before them. They sank into the snow. Engineers needed a design that could survive for decades without being swallowed by Antarctica's endless accumulation. Their solution was a massive, elevated superstructure resting on 16 hydraulic columns. As snow builds up around the station each year, the entire base can be lifted higher and higher, keeping it safely above the surface. This single feature alone dramatically extends its lifespan, which was estimated at 25 to 30 years when constructed. Neumayer 3 houses laboratories, workshops, weather centers, a command room, medical facilities, and comfortable living quarters. During summer, it hosts around 50 people. During winter, a much smaller overwintering team keeps the station operational while cut off from the outside world for nearly 9 months. This station is built to withstand some of the harshest Antarctic conditions. Katabatic winds that can exceed 125 miles per hour, extreme cold, shifting snow dunes, and complete isolation. And when its life cycle eventually ends, the entire station can be dismantled, down to the last bolt, and removed from Antarctica to comply with strict environmental rules. With its modern architecture and smooth aerodynamic design, New Mayer 3 remains one of the most advanced megabases ever built on the continent. Number 3. Concordia Station, France and Italy. Third on our list is perhaps the most extreme in terms of human endurance. Concordia Station, a joint French-Italian megabase known as one of the most isolated places on Earth. Opened in 2005, Concordia sits 10,607 feet above sea level on the Antarctic Plateau at a location known as Dome C. Because of the extreme altitude and dryness, the atmosphere here is similar to conditions found on Mars. Winter temperatures can drop to negative 112 degrees Fahrenheit or colder. The air's so thin that crew members live in a state of chronic hypoxia. The nearest station is about 620 miles away. The coast is about 680 miles away. The South Pole is roughly 1,040 miles away. In winter, Concordia is completely cut off. No planes, no vehicles, no evacuations, no resupplies. The crew of 13 to 16 people must survive on their own for months. Because of this isolation, Concordia is used heavily for astrobiology and human psychology research, including studies performed jointly with the European Space Agency. Scientists here study how humans cope with isolation, confinement, extreme cold, and disrupted circadian rhythms, all conditions astronauts will face on future missions to Mars. The station consists of 2 large cylindrical towers connected by walkways, one for living quarters, one for science. In the summer, the population rises to around 70 researchers, but even then, the station remains one of the most remote human outposts on the planet. Concordia is not just a research base. It's a psychological and physiological testbed for humanity's exploration of other worlds. Number 4. Belgrano 2 Base, Argentina. Fourth is a station that survives where almost no other structure could. Belgrano 2. Argentina's southernmost Antarctic base, founded in 1979. Most Antarctic stations are built on ice shelves or the bedrock near the coast. But Belgrano 2 sits on Bertrab Nunatak, a rocky island surrounded by glaciers, one of the few places in this part of Antarctica solid enough to support a permanent structure. Its predecessor, Belgrano I, was abandoned when the ice beneath it became unstable. To avoid repeating history, Belgrano II was designed with cold-resistant modules raised above snow level on sturdy stilts or skids. The entire structure is engineered to survive temperatures below negative 40 degrees Fahrenheit, polar nights, shifting ice fields, and relentless winds. Belgrano II is one of the southernmost research stations on Earth, while enduring some of the harshest Antarctic winters imaginable. Around 24 people live there in the summer, and roughly 19 remain through winter. This station conducts critical research in glaciology, meteorology, geophysics, medicine, and climate science. Its southern latitude makes it one of the best places in the world for studying auroras, atmospheric chemistry, and long-term environmental changes. Belgrano 2 may not be as visually futuristic as Halley 6 or as psychologically engineered as Concordia, but in sheer toughness and endurance, it stands among the elite. Number 5. Dumont-d'Urville Station, France. Last on our list is Dumont-d'Urville Station, a French research base located on La Da Petrel in Adel land. Established in 1956, it replaced Port Martin, an earlier French station destroyed in a fire in 1952. Dumont-Durville sits on exposed rock in a region known for powerful katabatic winds that can exceed 185 miles per hour, some of the fastest surface winds on Earth. These hurricane-force gusts shape every aspect of life at the station, from construction to logistics. The station conducts research in marine biology, ornithology, glaciology, atmospheric science, and climate studies. It's famous for its large colonies of emperor and Adélie penguins, featured in documentaries like March of the Penguins. Unlike many inland bases, Dumont-Durville does not rest on stilts because the rocky surface provides stable ground and significantly less accumulated snow than inland locations. However, what it lacks in drifting snow hazards, it makes up for in brutal windstorms, sea ice blockades, and dangerous coastal conditions. The station also serves as a crucial logistical hub for transporting supplies to Concordia Station via a 745-mile inland traverse, one of the most challenging supply routes in Antarctica. More than any other station on this list, Dumont-Durville has proven its staying power. Its long operational history, through storms, fires, isolation, and extreme weather, earns it a well-deserved place among Antarctica's toughest megabases. In a world where most buildings crumble under time, these Antarctic stations stand as proof that human engineering can defy even the harshest rules of nature. From drifting ice shelves to frozen plateaus, from crushing isolation to storms stronger than hurricanes, each megabase represents a different answer to the same question. How do you build where nothing wants you to survive? Antarctica keeps changing, and so will the research structures we designed to endure it. As long as there's mysteries to uncover at the bottom of the world, engineers will continue pushing the limits of what we can build and how far we can go.